This video is for Math 140 Trig, and it is on Chapter 12.6, Products, Quotients, Powers, and Roots of Complex Numbers. And in this chapter, we make use of learning how to add and subtract in polar form, how to multiply and divide in polar form, and with complex numbers. And then we learn how to use de Moivre's theorem to figure out the power of a complex number. So I'm going to do the problems that are listed in your book on page 363, because I think if you see them worked out, that might help you better figure out what we're doing. So this is chapter 12.6. And I'm going to start with problem number 5. And problem 5 lists this: 4 cosine times the cosine of 60 degrees plus j sine of 60 degrees times 2 times the cosine of 20 degrees plus j sine of 20 degrees. Now first note what we have here. We have a product. We're multiplying because they're side by side. A product of two complex numbers written in polar form because we have the r and then we have the theta. So another way to write this, when you use multiplication of complex numbers, what you do is you take the numbers out in front, which is actually your r, and you multiply them together because this is a multiplication problem. You then take your angles and you add them. So we have 60 degrees and we're going to add to it the 20 degrees. So we get 8 with this kind of angle sign, 80 degrees. Okay, and that is in another way to write it in polar form. Or if I wanted to write that out in polar form, it would be 8 times the cosine of 80 degrees plus j times the sine of 80 degrees. You've got to be able to go between all these forms rather easily. You won't be using much of the exponential form, so don't spend too much time on that, just to be able to do the problems that I'm doing on this video. Practice doing them. So that's your answer for problem number 5, and your instructions had been to perform the operation and leave the result in polar form. So it wanted the answer in polar form. Okay, let's jump to problem number 9. I leave 7 for you to try. In problem number 9, the directions say perform the indicated operation and leave the result in polar form again. Okay, so we have 8 times the cosine of 100 degrees plus j times the sine of 100 degrees, all divided by, this time we're dividing, 4 times the cosine of 65 degrees plus j sine of 65 degrees. Okay, when you divide, let me get rid of all these little marks. When you divide, the rule for dividing complex numbers is to take the numbers out in front and divide them, because that's what you're supposed to do. And then what you do is, in parentheses, if when we multiplied we added, guess what we do when we divide? We subtract. So we write the cosine of 100 degrees minus 65 degrees plus j times the sine of 100 degrees minus 65 degrees, which gives us 2 times the cosine of 35 degrees plus j times the sine of 35 degrees. Now ask yourself, is that in polar form? Yes, it is, because you have your r and your theta. So that's all you have to do for number 9. So now we've learned how to multiply two complex numbers and how to divide two complex numbers. You do different things. You put them in different formats depending on the problem that you're doing, whichever makes things easier. So let's look at problem 11. Problem 11 lists this: 12 and then 320 degrees divided by 5 and negative 210 degrees. This one's a little bit different. So we take our 12/5 and divide it. And then in parentheses, we're going to have the cosine of 320 degrees. Now, what are we going to minus? Well, we have this minus 210 degrees. Minus 210 would be, remember this would be, if we started here and went around, this would be 180, so it's going to be somewhere in here, minus 210. To figure out what it actually is, we could subtract it from 360. So 360 minus 210 would give us 150 degrees. So this is another way of writing 150 degrees. You want to put it in positive form before you work it out in this problem. So when I do my 320 and I'm dividing, I'm supposed to subtract when I divide. We're going to use this. We're not going to use our negative angle. We're going to use the 150 degrees. Plus j times the sine of 320 degrees minus 150 degrees. That's going to equal, that's a decimal, so you get 2.4 cosine of, times the cosine of 170 degrees plus j sine of 170 degrees. And that is in polar form, so we are finished. Now we want to look at number 13, and 13 is quite easy. I actually started at making it very hard, and you don't really need to. So let's go to a next page, and we'll go to 13. 13 lists this: 0.2 times the cosine of 35 degrees plus j times the sine of 35 degrees. And it's all raised to the third power. This is where you use de Moivre's theorem. The first thing you check is it in polar form? Yes, it is. We have our r is 0.2 and our theta would be 35 degrees. We're raising that to the third power. So de Moivre's theorem says here's what you do. You take the r, 0.2, and you raise that to the third power because we're raising the whole thing. So just raise that to the third power. But when you go to do your angles, you actually do times. You take the power 3 times 35 degrees plus j times the sine of 3 times 35 degrees. And that's all you do. Don't make it hard like I tried to do. If you just do this, it works out to be 0.008 times the cosine of 105 degrees plus j sine 105 degrees. And that's in polar form, so we're done. That's all you have to do. Don't do anything else with de Moivre's theorem. Don't try to find square roots. I don't want to do that with you. The only thing you're going to be responsible for on your test is a problem like number 13. Okay, so let's jump to 17. 17 states this: 50, and then your angle sine, 236 degrees, times 2, and then your angle sine, 84 degrees, divided by 125, and then your angle sine of 47 degrees. So we have a mixed problem here. So we start very simply by taking, let's do the multiplication on the top. So we take our 50 times 2, and then in our angle, or in our this sign, we would have, what do we do with our angles? 236 degrees plus 84 degrees. And we'll keep the bottom the same for right now. So we get 100, our angle sine, 320 degrees. Looks like a big angle sine. And 125, 47 degrees. And what do we do when we divide? We do 100 divided by 125. And then what's going to be in our big angle sign? You subtract. Whenever you divide, you subtract. So we're going to take 320 degrees minus 47 degrees. And that will give us 0.8 with our big angle sign of 273 degrees. Wow, that was nice. That worked out perfect. It was in polar form to begin with, and it ends up in polar form. Okay, problem number 23. Problem 23. Let me get a new page here and see how much time we have on our video. Okay, we might have enough time to get this done. 7085, 1115.62 degrees, minus 4667, and inside we have 296.34. I'm going to go kind of quick, otherwise we'll run out of time. So we take 7,085 times the cosine of 115.62 degrees plus j sine of 115.62 degrees. So first I'm writing it out in polar form. 4667 times the cosine of 296.34 degrees plus j sine of 296.34 degrees. Okay, so we're going to, here's what we're going to do. We're going to put this in our calculator, the cosine of 115.62, and then you're going to multiply whatever you get by the 7085. And when you do that, I'm going to say that again, do the cosine of 115.62, then multiply it, because you have to distribute the 7,085 to it afterwards. You're going to get these values, negative 3,063.5577, plus, same thing again, do the sine of 115.62 and then multiply it by the 7,085, and you will get 6388.4145J minus, let's do the same thing here, do the cosine of 296.34 and multiply by the 4667. And you will get 2070.7337 plus, and do your sine of 296.34 and multiply it by the 4667, and you will get minus 4,182.4575J. And this becomes simple math. Let me erase these for us here. This just, you're going to add like terms, so you're going to add this one minus this one, because the minus is outside, so it's got to go to both of those, because we're doing the two real parts, and then we'll do the two imaginary parts. So you get negative 5134.2914 plus 10,570.872J. Now we have to change that to polar form. That currently is in rectangular form. So we know our x equals negative 5134.2914, and our y equals 10570.872. What's our r going to equal? The square root of negative 5134.2914 squared plus 10570.872 squared. So r is going to equal, when you get that all done, because I rounded, I got 11751.77. The book got 11750. Lastly, you'll need to take the inverse tangent of y over x, and you will get a reference angle. Theta reference will equal 64.09, but remember, you're in the second quadrant because your x was negative and your y is positive, so you'll have to take 180 minus 64.09, and you will get 115.91 degrees. So that is your final answer, 11,750, and then that should be it for you.